Hello guys, okay, welcome to ICE Education. So today what are we doing? We are doing finite element analysis. So for those who remember when we started this topic here, I actually said finite element analysis is a it's a very nice subject to know. It is crucial in design, those who do manufacturing, those who do maintenance, uh, ooh, hey, petrol is going high. Oh, it's decreasing. Oh, this is nice. This is nice. Okay. So it means, yeah, if petrol decrease is nice. Okay, guys. The general formula that you need to know of the stiffness in this case, guys, it is A, E, L, and then you have 1 minus 1 minus 1 and then 1. Yet, I wanted to note you have three types. You have, let's read it, you have the bar element, a bar only in one direction, and you have a bar in 2 dimension. What do they mean by 2 dimension? This bar, for instance, guys, if you have an example, a bar is at a certain angle. This is why we call by 2 dimension. In this case, remember, let's forget about the bar even. If you have a Cartesian plane, if you have a force applied here, going here, F, definitely you know that this force here only has one component, which is in the x direction. So this is what we are doing here when we have a bar element going only in one component. That's why you see only x here. Now, there are some instances that we'll see later on the next part of this topic when the bar is at a certain angle. You can also consider it as a force acting at a certain angle. Because if I have F here, you do know that I'll have one component on the x-axis and I'll have one component on the y-axis. So same apply for the bar. So the only difference is when we talk about 2 dimension, we simply mean that the bar is at a certain angle. When we talk about one direction, it means a bar is lying horizontally. That's the only difference. So what we are doing right now, we are solving the case when we have a bar going on in one direction horizontally. So the most important thing that you need to know, it is this matrix stiffness that have been derived and been proved for us. There's no need for us to go and derive it. All we have to do is how to apply. So how do we apply it? First of all, you look at the problem, you have to read. When you read, they said for the 3 bars assemblage. They say 3 bar assembly because you have 1, 2, 3. It's an assemblage of 1 and 2, 3. Now, determine the global stiffness. This is the stiffness. Determine the global stiffness. B, the displacement of node 2 and 3. C, the reaction of node 1 and 4. I'll try to do this class in an hour so that you guys can have short recordings. So I don't know if you watch long recordings, if you have the willingness to go to read toward the ends, because sometimes it gets tiring. So we'll try to push it, maybe to do this problem in an hour if we can, but I believe that we can. And yeah. So who is here? Mr. Koso here? Yeah, he's with me. Now, they said a force of 1.5 Newton is applied in the x direction. This is the force that they're talking about at node 2 here. The length of each element is, you can see, 0, 0.6, 0, 0.6, 0, 0.6, and the total length is 1.8. Now, E is called flexible. Oh, Mr. Koso, English one Nisa. E is called modulus of rigidity. Rigidity. English. Mr. Abubakar. Rigidity. Hopefully I'm recording. Let me check.
Mr. Ice, my brother.
Sure, sure.
How are you, man?
You know, my
So,
brother.
then you know that we already like 40 minutes late, man.
If we keep talking, we'll be later, my brother. Let's work then. Now, an A 6 times 10 to the minus 4 for element 1 and 2. For element 1 and 2, they have the same area. For element the area is 12 times the minus 4 for element 3. Nodes 1 and 4 are fixed. If you remember on the previous chapter, I said if you have an end support like this and you have a node at it, it simply means it is a fixed point. So this statement is not a must for it to be in the question. When you look at your bar, you have this ending point like this and you have a node at this point. That simply means that you are having fixed point. And if you remember, at the fixed point, all the displacement of the fixed point are zero. That is one of the reasons that you have this information. So when you look at your problem, if you see a fixed point, just know that the displacement around that point is zero. Just a reminder to remind us. So the bank sent me a request on LinkedIn. Guys, if you're on LinkedIn, we can connect, guys. You can still find me on iState. That's my name on LinkedIn. Okay, now what do we do, guys? You look for the stiffness at each point. Now, what do I mean each point? You have point 1, point 2, point 3. These points are between nodes. Point 1 is between 1 and 2. Point 2 is between 2 and 3. Point 3 is between 3 and 4. Now, from the previous topic, I said if you want to know the type of matrix that you are expecting, if it is a 4 by 4 or if it is a 2 by 2, you simply look at the number of your node. You count the node. The node are this circle that you see here. This one is one node, this one is two node, this one is three node, this one is four node. So it definitely means that the matrices that I will be dealing with is a 4 by 4. Number of nodes gives you type of matrix that you are dealing with. It's straightforward, guys. So now let's look at element 1. If you look at element 1, you apply this formula, guys. Element 1. You apply this formula. So what do you get? Okay, again, guys, we can do okay. Element 1, let's do element 1. You can call this K1 like this. With this area is given as 6 times 10 to the 4. Right? Over L. Length is, we look at the length from 1 to 2, 0,6. What is E? E is the rigidity. Oh, guys, the name is giving me challenge. But E is given as 1 times 10 to the 11. Now, what do we have, Mr. Roto? We have minus 1. No, we have 1, minus 1, minus 1, and then 1. So if we take on our calculators, we do this calculation. I'm pretty sure, let's save time because this example is there. It is 2 times 10 to the minus 8, which gives you 1, minus 1, minus 1, and then 1. But now, remember, guys, what you are doing here. We
Okay.
can, yes,
Oh, the eyes.
yes, Madina.
That 1 minus 1 is part of the formula, ne?
Yeah, it's the general formula for this
Alright.
case. It's the general formula for when you have a bar horizontally. Each case has its own formula of finding K. This is only applicable for this case when you have an horizontal bar without an angle. Now, if you guys remember, there is a method that we were doing, like you expand each matrix by 4, but that one actually takes time. We're gonna do this time. We're gonna expand it because it's our first example. Let's say we're gonna call this one U1, this one U2, this one U1, this one U2. Now remember, we are having a 4 by 4 matrices. How do we know that? It is because the number of nodes give us the number of matrices. So it means for K1, you have to expand it to a matrix of 4 by 4. That is what you need to do. But yes,
Mr. Ice,
yes, my leader.
there is 2 times 10 to the power. What is that? 8, 3, or
It
2?
is 8.
8.
It is this answer I just took it from your note. So if you tap the calculator, if it is different, it means it's from the note. So K1 here, guys, it is 2 10 to the 8. You can expand these matrices if you can do it directly. But if you do it like this, you need to be fast. But it is safer to expand in such a way that you'll be having U1, U2, U3, and U4. These are the displacement. Same thing here, U1, U2, U3, and U4. The reason why we are expanding it by 4 by 4 because we have 4 nodes. That's the only reason. Now, what you do, you look at U1 and U2. This thing is between here. You have 1, you have minus 1, you have minus 1, you have 1. Everywhere that is nothing, you put 0. Now, you are done with K1. You move to K2. Same thing. But remember, guys, hey, why am I speaking good English? Remember. Remember, Mr. Kosa, K2 and K2 and K1 have the same area. That's what they say. The length, where is it again? The length of each element is this, is 0.6. E is this. I think I made a mistake. They said E is this and area is this for element 1 and 2. So for element 1 and 2, so it means the E here is not supposed to be 1, it's supposed to be 2. But yet it's not changing much because this answer I copied it right. But this is the right way of doing it because they gave you the rigidity for element 1 and for element 2. And they also gave you that the area, so they have the same area. So what does it mean, Mr. Rosso? It simply means the matrices of 1 is the same as the matrices of 2. Now, what is the difference? When you come to the matrices of 2, you will still have this answer, guys. Why is it the same answer? Because you do have the same E, the same A, and the same length, you can see. So definitely it is the same answer. But what is changing? What is changing here? This element is between U2 and U3. That is what is changing. U2 and U3. But still, you have 1, you have minus 1, you have minus 1, and you have 1. What do you do after here? You expand to a matrix of 4. And I'm going to repeat myself one more time. The reason why we're expanding by a matrix of 4, because we have 4 nodes, and 4 nodes simply means we have a 4 by 4 matrices. I think I'll be repeating it throughout until it gets through our soul. Now, we have U1 still, we have U2 still, we have U3 still, we have U4, And then here we are. So, Mr. Grodzo, we have U1, U2, U3, and then U4. You do this like this is when you play safe, and if you want to do it like this, please be fast on the test. Or you can do it directly. Directly is riskier, but okay, the safe way is a better way. So let's play safe. Now, you know U2 is between U2 and U3. So you come between U2 and U3 here. You have 1, you have -1. Where is U2 and U3 again? No. I'm the one mistaken this thing. I'm putting it where there's U1. U2 is here, U2 is here, so 1 is here. U3 is U2 and U3 they are here. So 1 would be here, -1 here, -1 here, and then 1 here. The rest is 0. Easy as that, guys. You just put 0 everywhere. You have expanded it to a matrix 4 by 4. Now we move to the last element, which is K3. So what is K3? We still use the general formula of AE over L, but now for this case, E is different, A is different, but the length is the same. So what do we do, Mr. Grotso? What do we do? We replace. What is A? The area here is 12 times 10 to the -4. What is it is AE. What is E? E is 1 times 10 to the 11. What is L? 0.6. Yet again, Mr. Grotso, we do have 1, -1, -1, and 1. Guys, do you know the reason why we leave this thing outside like this, guys? This value that you see here, do you guys understand why we keep the value out? Because it's important to know. The only reason is because this value outside here is multiplying everything inside here. So it simply means instead of having 1 here, you are supposed to have 2 times 10 to the 8 minus 2 times 10 to the 8, 2 times 10 to the 8 minus 2. You see this value? It should be inside here. But to avoid having such value, a big value inside the matrix, what we usually do, we take this guy as a common factor. That's what it means. You simply take it out and you can have the 1, 1, 1, 1 here. That is basically what it means. So the reason why I'm telling you that, because there will be some instance in the question where you cannot create a relation. In that way, it means you will have to multiply this guy inside and do the addition. You will see what I mean as we proceed. Now, if you do that calculation, that guy gives you what value? Fortunately, on this case, under this case here, if you take your calculator, this answer is also giving 2 times 10 to the 8. It's a coincidence. It is just a coincidence. So now, this point is between 3 and 4. So here you have to have U3. Here you need to have U4. Here you need to have U3. Here you need to have U4. But you will see in the cases where this is different, this is different, this is different, what do we do? You will see it even as we proceed. Now what do we do here, guys? We expand this matrix as well, K3. Global stiffness, what is it about? You expand this, you're gonna have 2 times 10 to the 8. Now if you expand, remember, it is still U1, U2, U3, U4, U1, U2, U3, U4. Now, remember, it's between 3 and 4. This is 3 and 4. This is also 3 and 4. So this down here. So you come here, you put your 1, minus 1, 1, minus 1, 1. Everywhere now you put 0. You are done. Now, what is the global stiffness K? The global stiffness K, it is simply the sum of K1, K2, K3. That is the sum of it. That's the global. So what is that sum? It is 2 times 10 to the 8. You open, it is U1, U2 still, U3, U4. This side here, it is U1, U2, U3. I think you guys should get used to this because on this chapter we'll have a lot of matrices, a lot of U, a lot of what, so you'll hear it a lot. But okay, what do we mean by this? The sum is simply simple. You add everything. Normally the way I do it directly. Like I simply take this matrix of this guy, I add quickly. But like I said, let's do it safe. In a safe way, what do? We add each element. 1 plus 0 plus 1. What is the answer? It is 1. You add each element. Each element. You can do it row 1 like this for everyone. Minus 1, 0, 0 is minus 1. Now you are having the global still. You are adding everything. Look at how we are doing it. First row of this one is adding first row of this one is adding first row of this one. So if we have 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 it is 0. That's the reason why here we do have 0, 0. Now, what else do we need? We move to the second one. The second one is minus 1, 0, 0 is minus 1. Now you're having the global stiffness, Mr. Grodzo. Now we move to this one here. Oh, here we have 1 plus 1. This is nice. Plus 0. So this one here is giving us 2. Now we move again. 0 minus 1, 0. It is minus 1. Scroll again. 0, 0, 0, give us 0. Hey, come here. This is U2. Let's go to U3. U3, what do we have, guys? Okay, you have 0, 0, 0. It gives you 0. 0 minus 1, 0 gives you minus 1. What is Mr. Grosso and Mr. Bubakar? 0, 1, 1, 0, 1, and this one give us 2. What is 0, 0 minus 1 gives minus 1. This is the global stiffness. Last row, and then we are done. You have 0, 0, 0. It gives you 0. Easy as that. You move again. Guys, I hope you guys are with me, right? 0, 0, 0. It gives 0 as well. So after here, I need to cook my butter. 0, 0, minus 1 give minus 1.
Hey, Mr. Alice,
Yes, my leader.
take it easy, man. Take it easy. I don't cook him today.
You are saying, my brother?
Listen, you see the 2 times 10 to the power 8? I'm saying if you see the 2 times 10 to the power 8, what happens if it was not the same for all the case?
that's a good question,
Let's say
Mr.
like
Koso.
the other.
Let me fill this thing and I'll answer your question. 0, 0, 1 gives 1. Okay, what was the question again, Mr. Koso? Let's say this wasn't the same. That's the question, right, Mr. Koso?
Yes, yes, that's the question.
You create a relation. If the relation does not work, you multiply out. Okay, here's what I'm saying. I think a very, very good typical example is this one. I think I should open this thing of 2 bar. This is a very, very typical example. Forget about what is here. I just want to show you how to create a relation. Do you see K1, Mr. Koso? Do you see it? Please, you can open your mic. We
Yes,
can
I see
discuss.
it.
Do you see that the value here, this over 3 here, is the same as K3? Forget about this fact, forget about this.
Yes, yes.
Now, do you look at element 2? What is different?
So root 2.
The root 2. But if you want to make everything the same, what do? What basically happened? They divided everything here by root 2, everything inside here. That's why the value is changed. Now, if you divide everything by root 2, now you have the same thing. In such case, you need to create a relation. Or if the relation doesn't work, you need to multiply out. Now, let me bring you another example from what we are doing, because I know this one is a bit, you can see what I'm saying, but it's a bit rough. Okay, Mr. Koso, let's look at let me just change something from what we are saying. You agree that, let's say, K1 is 2 to, it is what it is here, 2 times 10 to the 8. K2 is, K2, let's say it is, K2 is 4 times 10 to the 8. And let's say K3 is, K2, it can put 6. I want it to be a multiple of 2 so that we can see what's happening. What divide by, okay. Anyway, let's just keep K3 to be 2 times 10 to the 8. Okay, what I'm trying to say here, Mr. Kotso, in this case, this one is different, right? But me, I want them to be the same. What will I do? Do you agree that if I divide this equation by 2, if I divide 4 by 2, I will basically have, why is this mass doing? I will basically have 2 times 10 to the 8. Do you agree with that, right? That simply means,
Yes, yes, yes.
it simply means that inside my matrix, all these values should be divided by 2. Now I created a relation. In that way, I can still use 2 times 10 to the 8 as common factor and do my addition. Now, this is what I was explaining earlier, Mr. Code. So I was saying that these 2 times whatever here, it is supposed to be inside the matrix. Because it is the same element throughout, we take it as a common factor. What do I mean by that? Normally, what we are supposed to do, Mr. Koso, it is 2 times 10 to the 8 plus 0 here plus 0. It gives you 2 times 10 to the 8. Instead of saying that, we take 2 to the 8 as common factor. Basically, what I'm saying is this one. If you have 4x plus 4x squared. Do you agree that, Mr. Code? So I can write it like this. Do you agree? Do you agree, my question, Mr. Koto?
Agree.
So it is the same thing that is happening here. The reason why I'm showing you this, Mr. Koto, it is only that if you cannot figure out a way
Yes.
to create a relation, multiply this guy inside everything here and do the addition. It's gonna be long and big, but you're gonna get the right answer. Sometimes the longer way is the better way. But you will see, that's a good question. You will see when we start solving such case, it will get easier. By tomorrow, I think we should do something like that. Okay, this is the global stiffness. So what is the next question, guys? Next question, if you read here, what is the question? Displacement of node 2 and 3. Yeah, very, very important. Everything now that we work on now will be for, we will use the global K. If you remember displacement, I said when you have a spring, force is equal to K times X. X is the displacement. K is the stiffness, everything that you see here. It is the same approach. So what do? We write our function, Mr. Grotsu. You have F1x, you write it. F1x, F2x, F3x. You'll ask me, how do I know that I have F1, F3, F4x? Because I have a 4x4. 4 node 4x4. 4x4 means 4 force. It is just like that, my guys. Very straightforward. Now, this is the force. What is K? K is our guy. K is our matrix that we got. It is 2, everything that you see here. 2 times 10 to the 8 multiplied by 1 minus 1, 0, 0, minus 1, 2, minus 1, 0, 0, minus 1, 2, minus 1. So what does this mean? If you no, let me not say fact up. Yeah, let me just say it. If you fact up the matrix, you are fucked up. Now, what is x? X is the displacement, what we are looking for. U1, displacement U1, U2, U3, U4. So guys, if you are asked to solve for the displacement, even if you don't know what you are doing first, write this formula. It will give you a clue. It will give you a clue. Mr. Bubakar, let's finish these things. Me, I want to cook and sleep. Yeah. Important thing, if you remember from the question, they said fixed node. Fixed node, I said it simply means displacement at the fixed node are zeros. That is the reason. Very, very, very important, guys. You have to note that. You have to note that. So what does it mean? To actually see it, you come on U1. Remember, this side it is also U1, this side is also U2, this side is also U3, this side is also U4. So if you want to see it properly, you can see U1 here. Because it is 0, you can draw a line like this to cancel, just for you to see what you are doing. You can do it outside the paper when you are writing a test, just to give you a clue. You are cancelling U1 here, you are also cancelling U1 here. U4 is this side, U4 is this side, cancelling U4 here. You are also cancelling U4 here. So the only guys remaining, it is U2 and U3. And then the reason why these things are cancelling like this, it is because displacement at u1 is 0 and displacement at u4 is 0. So why are they 0? Because they are fixed point. The reason why I'm showing you the line, it is for you to see that you only gonna be dealing with the row u2 and u3. So what does that mean, Mr. Clotso? Your equation will change. What are you going to be dealing with? Only f2x and then f3x, which is what? 2 times 10 to the 8. Now, what are our guys? Our guys, it is simply u2 and u3, which is these two here, which is 2 minus 1 minus 1, 2. Now, remember, vector multiplication, my people. This one should be u2. This one should be u3. Any question first, guys? Any question first? Okay, I believe that you guys are with me. Okay, what is the important thing to notice as well, guys? What is f2x? When you look at your problem, everything will be provided. Are you having any force at node 2? Yes, 1.5. So that means that that is the force f2x. Which direction is it going? This direction or that direction? Tensile or compressive, if you remember. It is going on the x direction, you can see. So it means this force is positive. At node 3, do you have any force? Let me see, maybe it's a network. You guys are still with me. At node 3, do you have any force? No. So it means the force there is 0. That's one of the reasons when you do come here to solve your problem, you have 1.5, you have 0, you have 2 times 10 to 8, you have 2 minus 1 minus 1 2, and then you have u2 u3. Vector multiplication, guys, if you remember, this row will be, and this row, what do I mean by that? 1.5 would be equal to, remember, this 2 times 3 is multiplying. That's what I was saying, is multiplying out. 2 this times 2 this give 4. That's the reason why you'll have 4 times 10 to the 8. Multiply by what? Remember, u2 is multiplying here, u3 is multiplying here, just like in vibration. Just like in vibration. This one will give u2 minus 2 times 10 to the 8. You have u3. So this side will be 0 to be equal. Same thing, guys. u2 multiply this, u3 multiply this. So what do we have? 2 times 10 to the 8 is negative here, u2, and then 2 times 2 gives 4, plus 4 times 10 to the 8, u3. Any question, guys? Now you have to solve for u2 and u3. So I don't know how you guys solve it. When I used to have my Fea calculator with Vusi, with the lecturer, I was just typing this in the calculator and type the answer. He was giving full marks. But if you do not have a Fea calculator, you go the hard way, guys. You need to go the hard way. Hard way is you make a relation.
The long way.
Yeah. Out of this, and then, but because of you, we'll try to do it. We'll try to. It simply means you can bring this guy, you can use this equation down here. you can say 2 times 10 to 8 u2 to be equal to 4 times 10 to 8. Do you understand why everything is becoming positive, guys? I just brought this negative on this other side. That's the only reason. So it means 10 8 cancel 10 8. You have a relation here. So basically you can go that u2 will be 4 divided by 2. So it means u2 is 2 times u3. Now you take this relation, you bring on the first one. Guys, we are doing advanced diploma. We shouldn't be doing these things again like this. So now, where does u2? You keep u2, which is 4 times 10 to 8, minus, where there is, no. Where there is u2, you replace by 2 times u3, yeah. Where there is u2, you will replace by 2u3. Minus 2 times 10 to the 8 u3. So basically what is happening here, you will have an addition. You'll have 2 times this, 2 times 4 gives 8. 8 minus 2 gives 6. So the answer here will be 6 times 10 3 u3 to be 1.5. Oh guys, you see the calculator. What is u3? u3 will be 1.5 divided by this answer. The answer will be in meter. Do you have a calculator? If you don't have a calculator, you can just copy the answer here from the lecturer's note to save time. But we can calculate to make sure. What are we getting for u2? Here we got 5 times 10 to the minus 5. 2 for you. What are you guys having? When you calculate u3, what do you guys have? Me, I think I'm having 0.25.
Guys,
Yes.
oh, so
No, not 0.25.
it's 1.5.
Yo,
Huh?
it is
That one is 6.
0.00025.
Tell me that
Mr.
one is
Antoine, is that 6 or 2?
It's 6.
is 6.10 to the power what?
8. Remember the power was 8.
I'm saying, isn't it supposed to be 2? Because it's 4 minus 2, not 4 plus 2. I'm not. Oh, sorry. I see now.
2 times
Sorry.
4, 8, and then minus 2, 6.
So what are we getting, Mr. Ice?
Me, I'm getting 0.0000025, which is what the lecturer got.
Yeah, I'm getting the same thing. Yeah,
2.5
I'm getting the same thing. Yeah, 2.5 to the power 10. Sorry,
negative 6.
2.5 times 10 to the power minus 6.
Yeah.
Yeah.
Or, I don't know how you wrote it here. Let's see. Oh, you got minus 5. It's supposed to be minus 6.
You know that man is always sleeping.
Yeah, it's supposed to be minus 6. So if you find this one, and remember, u2 is 2 times that. u2 is 2 times that. So you know that u2 is basically 5. 5 times 10 to the 6 meter. You already created a relation. You say that u2 is 10 times u3. So it's already here. The answer that you find here times 2, you get this answer. Now you have solved for the displacement. Easy as that. But yet again, guys, you do not have to do all this if you have a silver calculator. But if you don't have, you have to do this. Unfortunately, you have to go the harsh way.
The long way, Mr. Ice.
Okay, guys, let's push. Like I said, it's already 45 minutes. I think time clocked already. Let's see if we can finish this problem in 13 minutes. I don't want to have a very, very long recording. We are left with 12 minutes. Where is Andile Mabuza? Cindy, are you with me? Am I too fast? See, indeed.
I'm following. I see.
Hey, don't say I see, Mr. Kotso. Hey, Mr. Kotso, you see now. The left. What am I reading now? Okay, reaction at node 1 and 4. Ooh, this is important. What are the reaction force? Yet again, it is still this general formula that we are using. But now, how do we get the reaction force, Mr. Koso? Reaction force, it is simply solving each force with its displacement. Now, what do I mean by that? What I want to do, instead of writing this thing again, I want to use the power of technology. I want to copy. But you, unfortunately, during the test, you cannot do what I'm doing. You cannot copy. It means you have to rewrite. But me, since I'm using software now, I can do it. I can do this. You see the difference, Mr. Bubaka? Control Z. Let me paste it here. Move. Nice. Now, okay, there's some stuff that I need to remove. Delete. Nice. Delete. 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 Nice, Mr. Kotu. Okay, if we are looking for the reaction force, it means for each force. Now, you don't have to write. Basically, what I'm trying to say is F1x, you need to solve for F1x. What is the force reaction x? You'll have, remember, these 2 here is multiplying inside here. You'll have 2 times 10 to the 8 multiplied by u1 minus 2 times 10 to the 8 multiplied by u2. Remember, it is u1, u2, u3, u4, so forth and so on. You will go again, but remember, guys, these two are zeros, so you don't have even to continue. That's the good thing. And again, this one also, it is 0 here. Why, Mr. Koso? The displacement at u1 is 0. It is a fixed point. So the only calculation that you have, it is minus 2 times 10 to the 8 multiplied by u2. So what is u2? You found it. That's one of the reasons why you found the displacement. What is the answer, guys? That is it. You do for the first one, you do for the second one, and remember, at the end of the day, the sum of these four should be the same. You will see what I mean. It is a reaction force. Remember, you have two things going like this. One support here. So this reaction here, one should be equal, adding with some. You see what you will just see from the calculation what I'm saying. Can you please calculate this one? So for the second one, my guys, you do the same thing. You also have 2 times 10 to the 8 multiplied by u1, but this one is negative. You don't have to continue, guys. Okay, let's to avoid multiplying a lot and what I was writing everything that you can see. You know that u1 is 0, so it means that this first part you don't have to write it. When you come to the second one, okay, you do have u2, but what is happening? 2 times 2 gives 4. You have 4, 10 to 8 multiplied by u2. Okay, u3, do you have u3 here? Remember, this is minus 1 times this, give minus 2, 10 to 8 multiplied by u3. Now, okay, this one is 0, no need even to continue. And you also don't have u4 as a fixed point. You don't have to go further. So here again, Mr. Kosam Bubakar, we do the same thing. Can you please calculate with me? I want to prove something with the answers. Ooh, I forgot. 10 to the 8 u2. What is u2? u2 is 5 times 10 to the minus 6 that we calculated minus 2 times 10 to the 8. What is U3? U3 is 25 comma 10 to the minus 6. Please answer. We do the same for F3. These are the reaction force, guys. You should solve for each force. F3, this time this gives 0, so forget already. We have U2. Okay, this time this will give minus 2 times 10 to the 8 U2. This time will give 4 plus 4 times 10 to the 8. What is the guy here? U3. What else? This time this will give minus, but remember, it will come with U4. U4 is a fixed point. It is 0, so don't need to write it. Again, you come here, you're gonna have minus 2. Guys, please redo this example. Redo it to understand it. If you can understand it, you should be fine as we proceed. Please redo it. U2 is 5 10 minus 6 plus 4 4 10 to the 8. What is U3? U3 is 2 5 10 minus 6. Guys, please give me the answers, please. I want us to finish this question. How many minutes remaining? 6 minutes. We need to finish it in the next 4 minutes. We go again for F4. What do we do so that we can have a nice recording once? For F4, what do we do? Okay, F4 is even nice. This is 0, this is 0. Do you guys see it? So what is left? Simply minus 2. Do you guys see it? This multiplied by this. Minus 2 to the 8 multiplied by U3 only. That's only it. Because remember, this guy gives 0. U4 is a fixed point. So guys, it is minus 2 10 to 8 multiplied by U3 is 2 5 10 minus 6. Please guys, we don't have time. Copper calculator, let's get all this answer please in 4 minutes. Please do it with me. Okay, here I'm getting minus 1000
For F1
for F1.
is
For F2, what do you get?
it's 1 times 10 to the power 6.
It is 1 times 10 to the power 6.
It's negative.
Negative. For F3,
Yes.
no, for F2 here I'm getting 1.5. I don't know. Can you please recalculate? I'm having
Me too,
difficulty.
Mr. Ice. I'm getting 1,500
500
positive.
Newton, positive. Please, this is negative. For the second one, what? Can you please check again? We have 2 minutes left. Mr. Rodzo. That was gonna be strange. Let us house big. You get 0 here.
Yeah, 0.
Minus 2, 10, 8. 2, 5, 10 minus 6. It is their reaction force, minus 500. Their reaction force, Mr. Kotsu. Do you see what I was saying, that this force should be the same? If you add these two here, minus 500 Newton. is the same as 1.5 Newton. The only difference, what does it mean? This one is F1, right? Negative. It means he is reacting like this. That reaction force is going in this direction like this. No, it's going this way on a negative direction. It means the reaction force at 1 and 4. Where are they? The reaction, okay, it actually makes sense. The reaction force, it actually makes sense. Do you see it, Mr. Koto? This actually makes sense. Why am I saying that, guys? 2 minutes left. Let me explain it quickly. The only force applied under this system, it is 1.5. So it means this support point, they should add in a way that they cancel out 1.5. That is one of the reasons why at these 2 points here, you have negative 1.5 and negative 5 in such a way that they counter attack 1.5. That's the reason why we talk about reaction force, because they are reacting. What you give is what you receive. If you give 1.5, you will get 1.5, but in a opposite direction. It's the law of nature. If you put the effort, you get the result. You don't put the effort, you don't get it. So that was it. I don't know if we have much time. I will send a link. We can have a quick look on this question together so that it can be a productive night tonight. We can have is there a question to do here? No, this was the, we can have a look and do this question quickly. We do it quickly and then we sleep, guys. Let me send a new link, guys.